Hello, everyone. Hope you are staying safe and healthy. I'm Ekta, and I will be hosting this webinar. We had an amazing session on data science for product owners yesterday by Stephen. Today, I welcome you all for the webinar session on data science with Python Foundation by Lucy Shepherd. In this webinar, she will talk about how to train and test machine learning models with scikit-learn. Lucy is data science trainer at Go Data Driven. She trained as a teacher before spending 4 years working for a UK bank building models to generate customer risk profile. She now feels extremely lucky that she can combine her skills in data and her passion for teaching to share knowledge and support the next iteration of data scientists. So without much ado, I will hand it over to Lucy. Listeners can type their question in Q&A window. Lucy will address the question. Thank you so much.
Okay, thank you very much, Ika. That's very nice. It's nice getting an introduction. I don't usually get an introduction when I do my trainings. I usually introduce myself, so it's a bit strange hearing myself get introduced, but I also have a little bit of an introduction that I think actually Eka just covered everything, and I don't think I have anything more to say. So it's great to be here. I'm really excited. This is one of my favorite topics. So we're going to be doing data science with Python Foundation, a training taster. So let's just go ahead and get started. So here's my about me slide, but like I say, I think everything's already been covered. I'm a data science educator at Go Data Driven. I spent some time as a maths teacher back in the UK. So I'm actually originally from the UK. I also spent 4 years in a UK bank doing building models that predicted the level of risk of lending money to people. So really looking at how we can determine the level of risk and whether we should and should not give people loans, mortgages, those kinds of products. And then I really wanted to combine these two skills. So I really enjoy my data analysis and my data science, but I really wanted to go back to that training and teaching that I really loved from my years as a maths teacher. So I was really lucky to actually find a role where I could do that. And that's exactly why I'm here today as a data science educator at Go Data Driven. So this session today is going to cover off a range of things. We're going to look at Python. We're going to look at how we can use Python for data manipulation. We're going to look at it for visualization. And then we're also going to look at it for scikit-learn and how we can train models using that Python library, that scikit-learn library. So I'm going to just share a new screen, which has the work I'm going to be using today. And because this is a training taster rather than just a presentation, I always like to make sure my trainings are very interactive. So even though, we've not really met before, and usually with trainings, you spend a couple of days together and you get to know each other really well. We're going to pretend like we know each other really well already. And I'm going to share a link with you in the chat. And what that link's going to do is it's going to set you up in this environment, the same environment I'm working in now, which is going to allow you that whenever I do any kind of demos or code alongs, you can do it as well. You can run the same things that I'm running, and you can play about with it, and you can change parameters here and there and see how things change on your end. And you can give it a go. So I'm just going to share this link into the chat now. If you could just copy and paste it into a browser of your choice. It's not completely required. You don't have to do this. If you just would rather just sit and listen, that's absolutely fine. But I do think you'll get the most out of it if you follow along with me. It will take a few minutes to load, just while it sets up that environment. It shouldn't take more than 2 to 3 minutes. And by that point, we'll be actually doing some work that you can actually join along with. For now, I'm just going to introduce the session and just talk a little bit about what we're really doing here, why everyone's here today, and what we're going to cover. So if you have managed to open this and it is loaded, this should be the page that you see. Before that, you should see something that says binder and it should say loading. But once it's fully loaded, it should look exactly like this. And you can see there's different folders and files. And this is essentially what our training would look like. We'd have all these different folders and files that we can then go into and do some Python analysis. If you're familiar with Jupyter Notebook, you should be thinking, this looks really familiar and I'm really comfortable with this. If not, we're going to get introduced to it and we're going to get working with it throughout the next couple of hours. So I'm just going to go into this first file, which is called introduction. I think I need to reload my page, but that's absolutely fine. Let me just load. So this is exactly what you should see. Mine shouldn't take as long because I have already loaded this up. I wonder if I have this easy for me to get access. There it goes. It's not too long. Okay, so I'm just going to go into this first file, introduction. And all this is just an introduction to the course and a little bit about what Python is and what Jupyter Notebook is. So this is our agenda. So like I said, we're going to talk about Python and Jupyter Notebook. Then once we've done that, we've covered this off. That should only take about 5 to 10 minutes. We're going to get stuck into some nitty-gritty Python work and do some data manipulation. Usually when we do this type of course, and if you're brand new to Python, we take you through some Python essentials and some foundations of just Python purely, without going into the pandas library. But what we're going to do today is we're just going to jump straight into the full swing of it and get the most out of it, because we only have 2 hours today, so I don't want to spend too much time on discussing what a data type is and the lower level stuff. If you're interested in that, I'll leave you my details. You can always get in touch and I can point you in the direction of where you can learn those kind of fundamental skills. After pandas, we're going to look at some data visualization. And then after that, we're going to look at some machine learning. So we're going to look at what machine learning actually is. And then we're going to look at a use case using a penguins data set. So our whole 2 hours today, we're going to be looking at penguins and their measurements and how we can really define what kind of species a penguin is and how we can maybe go on to predict that. So let's start off with why Python, and all these sections, you can click on through to them. And if you're interested in how this is set up, you can always double click into the cell and see exactly what's happening behind the scenes. But I'm just going to use it as just a way to navigate around my notebooks. So I'm going to click this first link here, why Python. It's going to take me down to here. And there's 4 main reasons that I have for using Python and for really getting stuck into it. So I've just seen a message in chat. I will come back to it once I've just talked through this. So the first one is a high-level programming language. So it's often described as a batteries included language, and that's really due to its comprehensive standard library. Pandas is a very powerful library that comes on top of Python, very powerful data manipulation. And there's tons of other libraries as well that are out there for us available to use. So it's really available for us, not just for data analysis, but for data science, for machine learning, for artificial intelligence, for data engineering, for building pipelines. All these kind of things are available to us. It's highly readable. So in the late 80s, the creator of Python, who's from the Netherlands, decided he wanted a language that had really good code readability, and that he just sort of did this as a side project. But by 1999, this has become an actual language that he was ready to send out into the world, and thus Python was born. He was a really big fan of Monty Python, the Flying Circus. So if you are familiar with Monty Python, that's where it got its name. It's a nice kind of fact. Maybe it'll come up in a pub quiz once we're back in and back out in the world and we're doing quizzes again. The third one is a core skill. So I've put a percentage here, which doesn't sound very impactful, but in 2018 to 19, Python was named in 1.06% of vacancies, so job vacancies. And this went up to 1.28%. Now, it doesn't seem like much, 1% is very small, but we're thinking about every single vacancy that's out there. And this isn't just technical roles, this is all kinds of vacancies. And Python's now 20% more talked about in those vacancies than it was a year earlier. We talk about Python and we talk about it being the fastest growing programming language, and it really is for all these different kinds of reasons. So having it as a core skill is really, really useful to you and makes you look very desirable, not just for new jobs, but for the job that you're in at the moment. And finally, open source. So when I say it's open source, there's a few things that come with this, a few benefits. First of all, it's free to use. So Python's completely free. There's no kind of licensing costs that you need to consider with it. And there's a huge community that surrounds it. So it's not just the creator of Python that writes how the Python language is going to work. We've got the best data scientists and programmers across the world who are contributing to the Python language and the libraries that come with it. So not only have we got these people writing with some really good functionality that we can then access, it also means that there's this huge community surrounding it. So if we're trying something, we're trying something new, and we're maybe thinking this, how do I do this? Chances are someone's probably already done the same problem, and the answer's just out there on the internet for us to go and Google. So it's really easy to get answers super, super quickly. So hopefully that really rounds off for you why you're here today and why we're looking at Python. If you're already a user of Python, maybe there's a few things in there that you weren't aware of, and it's just really sort of solidified that belief that you're doing the right thing using this Python language. It's definitely one of my favorite languages that I've picked up from all kinds of programming. I did see in the chat that Bogdan said the website won't load for me. Oh, don't be sorry, that's fine. You can just follow along, and it might be something to do with the setup on your machine that won't load it. Alternatively, there's another link that I can give you which will send you through to the files on GitHub, so you can always download it from there. If you already have Anaconda and you want to do it locally, you don't have to do it in this environment. You can just do it from your own machine. But that's only if you've used Anaconda. If you haven't, I suggest just sticking in this environment. And if you can't do either of those, this session's still set up for you just to be able to follow along. So we've talked about why Python. Let's talk a little bit about Jupyter Notebook then. So again, if you're already familiar with this, you should this should all come flooding back to you. But we're going to be using Jupyter Notebook to do all of our kind of programming today. And you can either use this from the using what we have now, which is a binder setup, which is an environment that's just set up purely for this course. Or you can download Anaconda. So if you're interested, especially after this course, to getting into using this on a more daily basis, I'd suggest downloading Anaconda and using Jupyter Notebook from there. It gives you pretty much everything you need to get started with any kind of stuff we're talking about today: data analysis, visualization, machine learning. Everything's really comes available in that package, and it's really robust and easy to install. Why do people use it? Well, Jupyter Notebook allows for programming in the browser. You can see that I'm just in a Google Chrome browser, and you can choose your browser, and it's just really easy to get a hold of and work in. Another thing that people like about it is the layout. You can see that I've got some text here. You can see that below here, I've got this other cell where I can write some code in, which we'll do in a bit. And it really is great for telling a story, which I really love for training, and really kind of lays things out in a really clear fashion. And it's this, and along with the fact that it's just super easy, it's a super good playground for diving into data and really learning about your data. And that's why it's so popular among data scientists, which is a reason in itself to use it. If it's popular amongst other people, we're going to get a consistent approach to really applying data science skills.
So if you physics, because physics and NCERT is the worst thing to read. If you're sleepy, you read that. Okay, so I'm not sure. I think this might be someone who needs to go on mute, but that's so it always happens. I think it's the phrases of 2020 are coming back this year as well. You know, please go on mute. You're on mute. We can't hear you, and you're still sharing your screen, or we can't see your screen. I think everyone's really used to that by now. Okay, so I'm just going to do a quick reminder of what Jupyter Notebook's all about. And if you haven't used it before, this is going to be great just for you to get used to what it is that it's all about. So I mentioned the word cells, and that's really, really important when we talk about Jupyter Notebook. So you can see that if I select this cell here, you can see I've got this blue line down the side. It's selected this cell with all this text in. If I select the cell below, it's blue here, and you can see that there's nothing actually written in here. There's two different types of cells here. This one is a code cell. If I want to go from this blue selection to actually go in and edit it, right now I'm in command mode. If I want to go into edit mode, I just hit on enter or return, and it'll put my cursor inside there so I can now go ahead and type some stuff in. And maybe I want to, do some coding. I want to say, right, I want to figure out, what's 5 plus 11. Let's see if Python can do this. Start off with just some simple calculation. And I can run this by either hitting run at the top here, or I can hit on command and enter, and it will go ahead and run this. The star means that it's running. This is taking a little bit longer than I imagined it would. Let's just see if it sorts itself out. Let's try that one again. Okay, I'll work on that, make sure we can get this working. I might just pull in a new window to do so. But once it's run, it should come up with an answer 16. Let me see if I can actually get something going a little bit quicker. Okay, let's try this again. Okay, so what did I do? I tried to do 5 plus 11. So now if I go ahead and run this, okay, that's a lot quicker. That's exactly what I expect. Not sure why my other environment was so slow, but here we go. It's working a little quicker.
And saying, you know, my answer is 16, that makes a lot of sense. And again, I can either run it up here, or I can hit Control and Enter. I did say these two cells are slightly different. This is a code cell. You can see it just here. It says code. And if I select the one above, it's markdown. If anything happens where you accidentally go into this markdown file cell, it will look slightly strange if you're not used to it. If that happens, you can just go ahead and run, and it will format it and render it back to how we like to see it. It's a bit nicer on the eyes. It's also got some HTML in there. So if you're interested in how Markdown works in these Jupyter notebooks, I've put loads of different things in, like including images, including bullet points, formatting of headings and stuff. So if you're interested in how that's working, double click into the cell and just have a look at how it's done. You can look on that on your own time. We're not going to focus too much on it, but it is a really good language to get used to. Okay, so that's a little bit about how we can work with Jupyter Notebook. There's a few shortcuts down here. We talked a little bit about edit mode and command mode. So when you're editing in a cell and when you're in command mode, there's different shortcuts that you can use for different things. So we talked about the Control and Enter to run a cell. Shift and Enter, so if I go back and maybe if I change this to maybe 33 times 12, I don't just have to press Command and Enter to run it, I can hit Shift and Enter and it will run it, but then it will also select the cell below. So if you're wanting to run a few cells really quickly, just hit Shift, Enter, 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 and it will just run them one after the other. And then a few other things, just like other files, Control and S to save. And if you're in edit mode, you want to get back to command mode, just hit on escape, and you'll see that it goes from green to blue. So I'm now in command mode. Shortcuts in command mode, the most important one probably is the up and down key, which allows you to select different cells. A few other ones. Y will change the cell into a code cell. So you can see here, this is my markdown, but if I want to change it to code, I can do it here, or I can hit on Y and it'll change it to code. Doesn't make much sense because this isn't Python code, so it's not really very good for it to be in Python code. We want it to be markdown. So change it back to markdown, hit on M, and it'll change it back to markdown. And if I run it, it will render it back to how I like to see it. And then if I want to put in a cell and add a cell, so maybe I want to add a cell above, I can use A for above, and if I want to add it below, I can use B for below. So if I hit myself into command mode, hit A, I get a cell above, B, I get a cell below. If I don't want those cells anymore, just press D twice, and it will delete the cell. And you can also press L, which toggles on line numbers, which is quite nice if you're used to that way of working. And then finally, if you want more shortcuts, hit on H, and you'll see there's way more than what I've been talking about. So if you really want to get really efficient and effective using Python in Jupyter Notebook, definitely check out all those different shortcuts. But these are the ones that are going to be mostly useful for the level of what we're going to be working in today. Okay, so that's a little bit about introduction out of the way. Let's jump into some pandas. So I'm just going to click on here and click into pandas, and it's going to open up a new notebook with all our pandas working. And I can see my other environments caught up with us. Let's start exploring data sets, and that's what pandas is all about. So if you're thinking pandas, I'm talking Python, which is a snake, pandas, which is a bear. It's odd names, but essentially pandas is our library that you'll probably hear about the most for data manipulation. So what we're going to cover in this section, we're going to look at the data, our penguin data. We're going to import the pandas library and import our data. We're going to do some exploratory data analysis first to really get to know the data. From that, we might need to actually clean up our data, make it a little bit easier to use. And then what we want to do after that, once we've got our data in a really clean fashion, we do our in-depth analysis and really start thinking about any hypotheses that we might have and really see if we can answer those hypotheses. Then once to really kind of solidify that, we might want to do some plotting, and we're going to do plotting with the plot method, but also with the library seaborn. So that's the only other library we're going to look at in this section, and we'll talk about why we want to use that as well. Okay, and this is a really sort of good steps to take, really sensible steps to do load the data, explore the data, clean the data, in-depth analysis, and then some kind of visualization to really conclude your results. But let's go ahead and look at the data. So our data, it's all about these penguins. It's a data set called the Palmer penguins. The data was collected by Dr. Kristen Gorman, who worked at the Palmer station. And really what it is looking at all these different penguins on different islands, looking at their species, looking at some measurements, and looking at whether they were female or male. the goal of the data set really is to provide a place for us to do exploration, visualization, and scikit-learn, which is everything we're doing today. So it's the perfect data set. Let's go ahead and import our library. So to import the package for pandas, we do import pandas as PD. So I'm going to go ahead and run that. You can see it's run. I've got in fact, I might just restart my kernel. So if I go ahead and run, it should turn into a 1 because it's the first cell I've run. So this means the order of cells that I'm running. So often people ask is, why can't I just do import pandas? Well, you absolutely can. The problem with that is that every time you want to access a function that's available in pandas, you have to write the entire thing. Much more conventional is just to write PD, and then what you can do to access the function is do dot. If I hit on tab, you'll be able to see exactly what functions I have available to me. So I have all these different functions, and we'll have a look at some of these as we go through. But you can see I can do stuff with date times. I can make a data frame with this data frame function, and I'm going to use it a lot, and I don't have to write out the full word each time. I just need to write PD. So whenever you see any work online that maybe answers some of your questions, you'll probably see people writing this PD dot. So let's use that to import our data. So I'm going to import the data penguins, and I'm going to call it penguins in my file. And I'm going to import the actual CSV. I'm going to turn it into a PD data frame. So I can see that it's run. It's got a 2, but I can't see my data yet. So this is something that's a little bit different. If you're used to working in SQL or maybe SAS or even Excel, you're used to seeing your data a lot of the time. Python doesn't really do that. We have to tell Python we want to see it. And the way I can do that, I can just look at the top 5 rows. So this is default. We'll give you the top 5. By using .head. This is a method available in pandas. Maybe I want to look at the top 10 rows, and I get the top 10 rows. Careful though, because if you want to look at way more, because you think, you know, I'm more used to Excel, I want to look at loads of rows. It's going to really restrict what you see, because it's going to use up so much space in this notebook, and it's really not useful for us as a human to read this data. We want to get Python to do the hard work for us. So that's why defaults is probably the best to look at. We get certain information that we didn't have before. We know the names of the columns. Because we've got penguin ID, species, island, and so forth. We've got, if I slide a bit further this way, there's my the sex columns. So I've got sort of males and females. So I'm really sort of eyeballing that data to start off with. Other things that we can do. We can get the shape of the data. So I've got the shape here, 3, 4, 4, and 8. I wonder, people who've used pandas before will probably know exactly what shape does. If you haven't, you might be thinking, what does that actually mean? So I wonder if someone maybe can put in the chat, or just anyone can put in the chat, what do these numbers mean? What does 3, 4, 4 mean? And what does 8 mean? So just type it into the chat exactly what those numbers mean, and we'll have a look. Brilliant. So Vivek says rows and columns. Yeah, and in the right order as well. So 3, 4, 4 is the amount of rows we have, and we have 8 columns, and we could count them and just double check. But I'm going to trust Python that those are the 8 columns I have. So it really gives us the shape of that data. What else can we do? We can do describe. What does describe do? Well, describe gives us some stats, count, mean, standard deviation, min, max, and so forth on all our numeric data. Notice that we only get these 4 columns returned. Stuff like island and species, they were strings. You can't really calculate the mean of loads of different strings. So we just get the statistical data on numerics. It's kind of useful though, because we get some information about the mean bill length. We can see kind of, we're talking around 43 millimeters. We're talking about a mass of 4 kilograms or 4,000 grams. So we're starting to understand the data a bit more. So we're really doing this exploratory analysis. Maybe we want to just double check that, why do I only get these 4 columns? Let's have a look at the types. So if I scroll down now and do the types, you can see that these are my 4 types of type float, which essentially means anything with a decimal. My other ones are objects. Essentially, we can kind of think of these as strings or text fields. Pandas sees them slightly differently than just strings, but essentially that's what we're talking about when we see these objects. Maybe we want to do some things a little bit further. So we saw that we had some species. Maybe we want to think about, can we start thinking about how we're going to predict those species? Maybe first of all, we just want to know how many of each species we have. So what I can do here is I can first of all select my column by doing penguins, which is my data, open square bracket, and put in my column in there and close square bracket, and that will select my column for me. You can see I've only got the species column. But now if I put in value counts at the end with a open and close bracket just to call that method, now I get the actual number of penguins. I get 152 Adelie, I get 124 Gentoo, and I get 68 Chinstrap. So I've got quite a fair representation of those 3 types of penguins. Maybe we want to do the min and the max of the data. So I'm just going to take the entire data set and do the minimum and the maximum. So this was the maximum, and my next one is the minimum. Interesting thing here is that I get the minimum and maximum of the numeric, but also the text fields. And it's just done alphabetically. So what comes last alphabetically and what comes first alphabetically. So that's an important thing to note, that you will get those as well. But maybe I just want to look at one specific column. So maybe I want to select the column body mass and look at what the mean was. Now I did have that in my describe, but I don't want to have to, go over to body mass, look down to mean and make sure I'm in the right row. Maybe I just want to get that one value, and I can go ahead and do that. And I get my one value. So we said before it was around 4 kilograms, and there it is again. Why is that useful? Because if I want to then go on to use that data and maybe times it by 344, I guess that would be the total body mass of all the penguins, I can use that number straight there on the back. Maybe that doesn't really make much sense. Maybe I'll just keep that that mean value just to store it in my own understanding of this data. And then finally, what I think is one of the methods that we should always know about, we shouldn't have to Google how to do a group by. This is one of those things that we should know because there's so many different functions. We're not going to know all of them, but some of them we should have retain in our heads. And one of them is group by. Maybe we want to look at the body mass, but maybe we're thinking, actually, we had these 3 types of penguins. Do we expect the body mass for these types of penguins to always be around the same? No, I would expect that depending on the species, they might be a bit bigger or might be a bit smaller. Did someone mention something? Was there a question? Okay, if there's no questions, if you can stay on mute, but feel free to come off mute and ask me a question. That's absolutely fine. So what was I saying? I've got these 3 types of penguins, and I want to see what difference these types of penguins have on the mean of their body mass. So what I'm going to do is I'm going to say, right, I'm going to take this penguins data, I'm going to group it by the species, so I'm going to split it by species. Then I'm going to look at the body mass index and find the mean for individual species. And it kind of makes more sense when we actually run this and see what we get. So you can see actually that my original mean for the entire data was 4,000. But that's really skewed by the fact that Gentoo penguins have a much higher mean body mass than the other types of penguins. So already I'm learning more about this data. I'm learning more about how these species actually affect different aspects that I have. And one note, if you want to be a little bit smarter and sort of, well, not smarter, but you want to have this formatted in a nicer way, we can put double square brackets and it will just spit it out as a data frame, which makes it a little easier to read, but not necessary, but I like to do it if it's the final bit of my data. I just like to do it because it's easier to read. It's like nice highlighting as well. Okay, so we've done our exploratory data analysis. Now, one part of that was really just looking at the data that we have. We've done some further analysis, but if we just first of all look at the data, we might see that we need to do some cleaning. What is cleaning? Well, cleaning is all about taking our data and really making it fit for purpose. Now, what data science spend most of their time doing is just this, cleaning their data. If the last step was, so someone's asked me to read the last step, if it's group by, we'll come back to it. So we'll go over the group by step in just a few cells. So we can see here 60% of time spent by data scientists is data cleaning, which is a huge amount of time really. Which is, it's like 3 days a week out of the 5 days that a data science might work. If you also look at this article, which is just linked here, you'll see that another question that was asked was, what's the thing that you least enjoy as part of your job? And also the biggest chunk was data cleaning. So it's not the most flamboyant and exciting part, but it is definitely the most time that we spend, and it's probably the most important part to make the rest of our lives a little bit easier. So let's go ahead and start doing this. Let's look at the data. Okay, what might we want to clean up? And let's look at the first 10 rows here. So what might we need to clean up here? So again, just in the chat, if you can either do it directly to me or just to everyone, but just put some ideas that you have. What do you think we might need to clean up? Are there any columns that you think don't make sense? Are there any formats that you might want to change? Are there any sort of values that don't really marry up to other values? What about this data might you think there's something going on here that we need to address? Okay, so Vivek's put impute missing values. Yeah, okay, so we might see there's some missing values. If you haven't spotted them, they're just here. These NaNs, that doesn't mean anything for flipper length. It actually means not a number. It's really, for pandas, it kind of means that we've got some kind of missing data here. So we might want to do something with that. Anything else that people can see here that we might want to change? I'm thinking in the sex column, there's some things that like it doesn't really work for me. This column, I want to change something. Yeah, we've got something that says, okay, we want to change male to M, or we could do F to female, because if I've got male, but then I've got male and F, it's a bit, I have to do some logical reasoning in my head to change this to be male and female. And then the final thing that maybe I'm thinking, oh, someone said, do we actually need penguin ID? Yeah, we've got this penguin ID. Maybe we don't actually need that at all. I'm going to keep it in for now because it's a unique identifier for each penguin, but we might actually do something with that just to be a little bit smarter. And then the final thing I wonder if anyone can notice is to do with this column here. So looking at the other columns that we have bill length, bill depth, and flipper length. What can be misleading about these numbers? If I've got 39, 18, and 18, what could be misleading about those numbers, and what could we do to change it? Yeah, brilliant. We've got millimeters here versus centimeters. And you think about, 18 millimeters is like this. And then you think about a flipper length. Flipper length's not going to be about this long for a penguin. Well, maybe it's like a little baby penguin. But if their bill depth this long, it's just not going to make sense. So we want to probably change that to millimeters. To change that to millimeters, we want to times it by 10. So let's go about cleaning up this data. So what did we say? I'm just going to put those notes in here. We said we might want to change centimeters to millimeters. We might want to change F to female, or I think the suggestion was the other way around, but it doesn't really matter which one, as long as it's going to be consistent. Maybe we want to do something with the missing values. And then maybe we want to do something with penguin ID as well. And we're going to do just that. So let's go ahead and do it. And I've got some methods that we're going to use to do this. And what I'm going to show you now is pandas chaining, which means we'll do one method, then it'll spit out a data frame. Then we'll chain on another method, and we'll just do it one after the other, rather than saving a new data frame, then doing something new, then a new data frame. So because we'll end up with something like penguins 1, penguins 2, penguins 3, penguins final, penguins final, penguins, no, this is really final, I promise. And I'm sure you kind of felt that experience before. I know I have, with all different kinds of version control. So we're going to be a bit smarter. So the way we're going to do this, I'm going to, first of all, just write a couple of brackets, round brackets, open and close. And I'm going to hit enter in the middle. So I've got brackets sort of on multiple lines. And then I'm going to hit enter one more time with my cursor in the bracket, and it's going to indent this. And the reason for this is now I'm going to be able to write Python on multiple lines. Usually I don't get to do that. With these brackets, I'm going to be able to. And I'm going to reserve one new line for each new method I'm going to do. It's going to make things a lot easier to read. But the first thing I'm going to do is I'm just going to write penguins. And that's my data. So it just spits out my data at the moment. See, this, what I wanted to do first was change centimeters to millimeters. Well, I can use the assign function to either add a new column or overwrite a new column. So let's go ahead and do that. Let's do assign. And then my new column, well, what did I want to change? I wanted to change this column here, didn't I? Flipper length centimeters. And I don't want it to be flipper length centimeters. I want it to be flipper length millimeters. So let's just change that to millimeters. And then let's just take that column. How do we select column? Well, we select the data and we select the column within it, which is flipper length centimeters. And what do I want to do? I want to times that by 10, don't I? Because centimeters to millimeters I times by 10. Well, here I go. I can just times it by 10. It's a vectorized approach. It's super, super quick. There's no looping through lines. So it's really, really easy. If I go ahead and run this, you can see my new column here. And it's the same, isn't it? It's the same as this one, but just times by 10. I'm just going to add that one line into the chat so you can feel free to copy and paste it if you are following along. But don't worry, everything's going to be available. I'll show you how to get the full answer in just a sec. But what's the problem here? I've got flipper length millimeters. Do I really need the same thing in centimeters? No. So let's go ahead and use drop to drop flipper length centimeters. And the only thing we need to make sure about the drop statement is we also select which axes we're on. So 0 means the rows. I'm not dropping any rows. 1 means my across. It means my column. So I do axes equals 1. And you can see now that I've only got flipper length millimeters and my centimeters has disappeared. Great. So we're getting further with this. So we've done those first 3. Again, I'll just copy and paste this into the chat if you're following along. Maybe it's going a little too quick. You can just copy over it. The last thing I'm going to do, or the last couple of things, I'm going to drop the missing values. So someone said, can we impute this? You could impute them, but I think it doesn't make sense to impute them completely in this case. I know this data quite well, and a lot of times when we see the missing values, it's missing for every single column. So actually, it kind of makes more sense to just drop them because I can't really assume what these values are going to be because I'm missing too much data. So all I'm going to do is I'm going to do drop NA. Drop NA doesn't take any, well, it doesn't need to take any parameters. So I just open and close the brackets and I go ahead and run. You can see that my missing values have disappeared. Okay, and then finally, the set index. Not completely necessary, but I love this method because I use it so much. I'm just going to set the index as penguin ID. We're not going to see the real benefits today, but it's good to know that you can do this. Look at the difference now when I've set penguin ID. It's now, it was at the front already, but it's now everything's in bold. This is really useful for us to know about because it's going to make it give us a little bit more power when we're talking about the index. Like I say, we're not going to see it in action, but if I show you an example, maybe I just want to look at this one penguin, I can locate it using .loc. And it just gives me information about that one penguin. So I get it returned super, super quick. It's just like a key lookup value, just like in SQL when you have a unique identifier, a unique key. Right. I'm just going to remove that because I actually want the entire data. I don't just want one penguin. And now that I've got this data, I'm happy with it. I'm going to call this penguins cleaned. And now if I go ahead and run it, I don't get anything returned because it's now assigning a new variable. To return something, actually see it, I just need to call it again. And if I call .head, you can see all those things that I changed. The missing values are gone. Oh, I didn't change my female. Let's go back and just do that. But I've got my flipper in millimeters. I've got my penguin ID as the index. Let's just quickly add on my final thing. Which have I got it here? No, I don't. But a bit of a bonus. We're going to use the replace function to replace F with female. What this does is it looks for everything that's exactly the letter F. So not just any F that's in the data frame. So it's not going to change any Fs that are in here. It's going to change only if it's all exactly equal to F, which it's, I know that there's only values that are exactly F, only the letter F in this column. So I'm just going to go ahead and run that. And I can see I've got male and female, which makes a lot more sense to me to have it as consistent. If you didn't follow along and you just were a little bit lost, every time that we do any kind of coding along, there's always this load answers. You can see the answers here. And if you just run that twice, it will just run everything. It'll just run this for you, make sure that it has a number next to it. And then you can run penguins clean.head. You'll get exactly the same output as what we're talking about. Okay, a small activity then. I'm going to give you 3 minutes to have a go at these activities. There's 3, and they're different levels of difficulty. So if you're more relatively new, have a go at the star. If you want a challenge, go for the 3 stars. If you finish one, just go back to another or go forward onto another one. I'll give you 3 minutes and then we'll go through the answers. Okay, so if you've got any questions, feel free to put them in the chat. I've seen some people directly ask me questions. I'll get back to them in the chat as we do this exercise. Have a go at that. And if you haven't got this or you're not coding along for any reason, just maybe have a think about how you would do it. And you can feel free to send it to me in the chat and I can check out your logic. So even if you haven't got it open, there's still something you can do and just have a think about how you would do it. And maybe try just writing it, maybe on a piece of paper. And just while you're doing that, if you do get stuck, there's a hint just below, just about the syntax that you might need to use and the columns that we're in need of. And just check that you're definitely using the quotations around columns, column names. You do need to include those. So a little bit of a hint if you are getting stuck at any point. But try not to copy and paste, write it all out from the beginning. Muscle memory is very important when it comes to programming. Okay, so that's been 1 minute. I'll give you 2 more minutes to just see how far you can get, and then we'll go through some answers. Okay, so you should have had a chance now to have a go at some of those. I wonder then if in the chat you can maybe, if you've done it, if you've written it, if you could copy and paste it and just message it to everyone what your answer was. We might see people doing things a little bit differently. It doesn't matter which way you've done it, we'll just have a look at them. So if you feel free, put them into the chat. I'd really love to see them. It's great to see how other people code. I always learn something new, so I always encourage people to share. And we'll also just work through the answers now as well. So I wonder if anyone's going to be brave enough to drop that into the chat. Just keeping my eye on it. Okay. Oh, the answers are literally just below us. So you should see below that you've got some load answers, or maybe they're already loaded, but you can just go ahead and load them if you haven't managed to see them. I'm just going to do that now. You can see that if I want the mean flipper length of all the penguins, I take the flipper length, which is in millimeters now, remember, in my penguin cleaned, and I just do the dot mean with open and close brackets to work that out. And you see my flipper length is around 200 millimeters, not 200 centimeters, remember, because that would be 2 meters long for a flipper, which doesn't sound quite good. Maybe this time I want to see how many females and males there are. Well, that's my column here, which is sex, and I want to just count up how many values of each unique feature I have. So 168 males and 165 females. And then finally, the mean flipper length by sex. So this is that group by again. So we want the penguins clean data set. Now we want to do group by because we're splitting it by sex. We're getting the mean, but we want it split by sex. So in here, I just put my column that I'm splitting by. I'm going to just, maybe first of all, I'll just put mean. You can see it's actually done the mean for each of my numeric columns, but the only column I wanted was flipper length. So just before mean, or even just after it, I'm going to just select that column just with open and close square bracket. And now I only get the mean for the flipper length. You can see that for males, it's a little bit larger than females, which I guess makes sense with penguins. Okay, so that brings us to the end of our kind of exploratory data analysis. Now that we really understand our data, we might want to do some in-depth analysis. So this is less of a kind of a follow-on, but really kind of how, what's really possible. So there's going to be less demos, but more kind of what's possible. So here, I'm just thinking, I have this information about species. Maybe I want to know more about the difference between species. What does that actually mean when something's a different species? I could do my group by again, group by species, and get the mean for each individual species. So the mean length of a bill for Adelie penguins is around 38, but for chinstrap, it's much larger. It's 48, and so on and so forth. I'm getting more and more information here, and it's really interesting here. Gen 2 have really large beaks in comparison to Adelie, but their depth is very small, so they must have very pointy beaks, mustn't they? Because they must be very thin but very long. And there's also different islands in there. So now I have this information and I know that there's different species. Maybe I want to know how many species live on certain islands. So here I'm just going to pull in my crosstabs function, and I'm going to pull in my species and penguins and the island they were found on. I'm going to do a two-way table. So if I run this, I get my two-way table. Notice I've just got this extra line here. Didn't need it, but what this extra line does, you might see it, it just adds a total column on. So I can see the total number of species I have. But interestingly, Gen 2 penguins are only on the Biscu Islands and chinstrap are only on Dream. Interesting, where Adelie are on every single island. So a little bit more information that I'm getting here. So now that I've done more in-depth analysis, I'm going to move now on to plotting, because now I have these visualizations, I might want to actually visualize them in a chart. So the first thing I'm going to do is I'm going to plot this. So what I'm going to do is I'm going to use the .plot method to just start off with. This is built into pandas. I don't need any other library. And all it does, I've got my crosstabs. I haven't done my new total column, so I've got rid of this line here. But what I have done is just ordered this. Now this isn't completely necessary, so I'm just going to ignore this bit for now, but I've done my crosstabs and then I've done .plot. I'm plotting a bar plot. I'm making it stacked, and we'll see exactly what that means in a sec. And I've got a colored map here as well, which is Pastel 2. If I go ahead and run this, you can see exactly what I mean by this stacked. The different colors are the different islands, and you can see that Adelie have 3 different colors because they're on different islands. They appear on all 3 islands, but the other 2 do not. Gen 2 is starting to look a bit more dominant, because if you compare it to how many Adelie are on that island in specific, it's a lot larger. If at all you're struggling with the colors, just delete the color map section, just delete the color map variable. The colors are very good default for any kind of difficulty reading colors. They should be quite easy to read in default. But I quite like the color map pastel. If you're happy with that, keep it in. I think it looks nice because it kind of looks like penguin colors. But here I'm seeing visually a little bit more what's happening, and it's a bit easier to digest on the eyes. Furthermore, maybe I want to look a little bit further. So what about doing a scatter plot? Now I'm going to just import seaborn here. Again, you can see my convention is to import it as SNS rather than seaborn, just by convention again. First thing I'm going to do is I'm going to use the .plot method and just show you the difference here. So I'm using .plot, and then I'm doing a scatter plot, and I'm doing it on the bill length and the bill depth. So I'm interested to see is, as the bill length gets larger, what happens to the bill depth? Maybe you're sort of thinking in your head what you're expecting to see. Again, I've got a certain color. Again, if you don't like the color, just get rid of this last line and it will be a darker blue. I quite like this light blue because it reminds me of Antarctica and the penguins. So my plot originally kind of looks very nothing really. There's not really a relationship that I can see very easily here. Is this what we expect? Well, I'm thinking, no, I don't really expect this. I kind of expected as the bill length would go up, the bill depth would also go up. So I was expecting like a kind of clear, or maybe you see this way, it's kind of clear correlation, positive correlation. But it doesn't seem to be correlated. Are we getting the full picture then? So now what I'm going to do, instead of just doing .plot, I'm going to use the seaborn library, and I'm going to use this to get a little bit more information out of it. So here I'm doing pretty much exactly the same thing, but instead I'm accessing scatterplot from the SNS library, the seaborn library. I'm pulling in my data here. So syntactically it's a little different, but I've still got my X and Y. I've got my hue, this is new, which is based on species, and my palette, that's just again the color that I'm using. If I go ahead and run this, again, if you don't like the colors, just get rid of this last line. And it'll be sort of those orangey colors. Now if I go ahead and run this I'm getting a little bit more information from this plot. Look at how these kind of species are clustered. So my Adelie are this kind of blue color over here, light blue color, and my chinstrap over here. That has a lot more of a correlation. You can see that a lot more. It's kind of a line I could fit maybe as a positive correlation, and the same with the Gen2. So I'm getting way more information just by applying the colors, and that's available in that seaborn package. What else is available? Well, maybe I don't want to just compare bill length with bill depth. Maybe I want to think about all the other measurements, the weight, the mass that they had, the flipper length. Now that would be 12 different combinations if I wanted to compare them different, like one after the other. How about we don't do that? How about, again, we use the power of seaborn and we pull in pair plot from seaborn. All I need to do now is say pair plot, pull in just the data. It will find the numeric fields for me. I still need to specify hue and the palette that I'm using. But take a look at what happens now. It'll take a little bit longer because there's more going on. Okay, so I've actually got scatter plots for every combination of numeric features. When it's just, so you can see here I've got flipper length along the side with bill length and so on across the bottom. When it's comparing itself to itself, I've got a distribution. So you can see that flipper length for Gen2, well, Gen2 flipper lengths are a lot larger generally in this distribution. But where did I see, so what did I have before? I had bill length and bill depth. Let's have a look at that. I've got bill depth here and I've got bill length here. So that's pretty much the plots I was looking at before. But I've got those other interesting ones as well. Look at this body mass compared to bill depth. The body mass and bill depth is so similar in those two species, the blue ones, but in Gen2 it's quite different. And the same here when we look at the flipper length, which I wouldn't be able to see if I didn't have that extra color idea. And then flipper length compared to body mass, I also think is quite interesting, because if I saw that without color, I would immediately think, well, there's just a positive correlation. I wouldn't be able to see the difference in these species. But straight away here, I'm seeing that the flipper length and the body mass is much larger for the Gen2 species compared to the others. So something that's just one line of code, I have 16 plots and I've got so much information that I'm seeing here. This is just a real quick taster of what's available to us in visualization. There's a lot more, which we obviously can't get into because we've only got 2 hours together. But I encourage you to sort of just have a look at what we've seen today. And then we have our courses that go into in a lot more detail. And it's very, very interesting, all the different libraries. There's not just seaborn, there's matplotlib, which is what seaborn's built on top of. There's pyplot and other visualization libraries as well. Let's just refer back to these penguins. Look, here they are in the flesh. It's good to have knowledge of your data. So it's good to know what the data is saying on a numeric level, but you also need to really understand, does this make sense realistically in the real world? So I look at these penguins, I can see my Gen2 penguin is taller, a lot larger. So it makes sense that his mass is a lot bigger. And you can also see the beak. The beak is a lot thinner and longer than the other 2 penguins as well. So it's always good to have that subject matter expertise and refer back to it. So final thought on just what we've covered so far. So pandas can be quite frustrating, but with practice and Google, it can become straightforward and extremely powerful. Hopefully it's really showing you what's available and kind of inspired you to see what else there is to go about doing. We're going to take a quick break now, but if in the meantime, if you're interested and if you've done some code that you're really interested in, you want to save, you can download this notebook by going File and Download As, and you can pick it, or there's a download button up in the top corner, which, just here for me, you can hit that button and you can download it. Just be aware, you'll download it as a Python notebook file, so you need to have Anaconda to open, or you can download it as an HTML and then you can actually read that slightly differently. You can load it into a Chrome or other browser and you can read it rendered for you. Or alternatively, you can visit the repo. So you can hit here, visit repo, and you'll get all the files which you can download straight from there. So feel free to do that, and then you can have a further play. But this link will be open for you to just continually access if you're interested. For the kind of foreseeable future, I imagine for the next few months, they won't be taken down. Okay, I see some questions in the chat. What we'll do is we'll take a 5-minute break. So if everyone could be back and ready to go at 6 minutes past the hour. So I know we're all in different time zones, so that might be 36 minutes past the hour, but just 5 minutes from now. I will see you all then, and during that time, I will also answer some questions in the chat, and Aaron will also share that link again. Okay, I'll see you very shortly. Okay, welcome back. I hope everyone has managed to get back in time. I know there wasn't a lot of time to put a coffee on, but we'll be easing back into it. So if you're still kind of stirring the sugar into your coffee, do not worry. But I'm going to go ahead and get started on the next notebook. So if you haven't already, if you head on back to the kind of the folder page where you've got all the different files and you click on Palmer Penguins, it will take you through to there. Alternatively, if you were in introduction, you should see that we're now on the data science and machine learning part. So that's what we're going to talk about for the final hour. So I'm now in this one, Palmer Penguins, a machine learning example. So we're going to cover a lot in this notebook. And there's going to be a lot of concepts in here. So if you haven't done machine learning before, if you're relatively new to Python, some things may be a bit confusing. And what I would say about that is you're going to be sort of, just make sure you're comfortably lost. If you're really lost at any point, just message me in the chat and we'll make sure I stop and go through whatever we're talking about. But just kind of trust me on this. We're going to go through a load of different things. And what you'll find is that maybe you'll kind of be a bit confused today, but when you wake up tomorrow, you sort of settle down a little bit and you'll really reflect on what you've learned. And then you can come back to this and have another go. So there's going to be a lot to cover. I just want to make sure everyone's kind of on the same page and ready to go with this. And again, it's really about what's possible and what's really out there. I really want to give you an idea of what we cover in our course and really get somewhere with this and really get to a sort of final result. So what we're going to cover, we're going to look at data science, machine learning, what it actually is. We're going to meet the penguins, so we're going to talk a little bit more about the data. We've already come to really understand them, so this bit we'll skip over a little bit. Then we'll talk about the library, scikit-learn. What is it? Why do we use it? We'll load in the data, we'll prepare the data, but sklearn or scikit-learn, same thing. Then we'll do some model creation, the kind of fun bit. Once we've done our data cleaning, this is the more fun bit. Then we'll visualize that model and see how we can actually understand it. Then we'll look at how we can choose a different model. Those different models, those different algorithms available to us. Let's have a go at not just one today. So my first section, data science, machine learning. So I've got a quote here from a very prominent machine learning engineer who says that a computer program is said to learn from experience, which is E, with respect to some set of tasks, T, and performance measure, P. If its performance at tasks in T, as measured by P, improves with experience, E. So what we're talking about here is we're talking about how can we do a task? How can we sort of predict something? How can we say, I want to do something with some data and I want to then use this to do something else. This is my task. In terms here, we're talking about determining the species of penguins. So that's what we're going to look at now. We're going to look at if the data that we have available to us, are we able to use that to predict the species of a penguin? Our E, or the experience, is really the previously collected data. And that's from our penguins. We've got these key things that we're going to look at. And these are the only four we're going to look at for this model. We're going to exclude the others. I'll talk about why that is in a bit. We're going to look at the measurements of those penguins. And then we'll talk about P when we get to it, but it's really a performance metric. How accurate are we? Could be one. How accurate are we at really predicting this? Have we managed to get 80% correct, 90% correct, 100% correct? Really, where are we and where do we stand with that? So let's go ahead and start applying this. So when we're talking about data science is this big world, and machine learning is really part of that. And then inside there, you have other things like deep learning and neural networks. But really what we're going to do today is some more simple machine learning methods. So meet the penguins. We've talked a little bit about them, but here they are again, Chinstrap, Gentoo, and Adderley. Are we going to be able to predict what kind of penguin we have at each time? So we're going to do this by doing some kind of classification. And the reason we're doing classification, two different types that we usually talk about is classification and regression. Classification is where we really classify into certain groups. So we either have an Adderley penguin or a Gentoo penguin or a Chinstrap penguin. Regression techniques are usually used when we have some kind of continuous variable that we're trying to predict. Maybe we're trying to predict the house prices, or maybe we're trying to predict the amount of savings that people will have at the end of this year. This isn't that, is it? We're not trying to predict the amount of penguins we have. We're trying to predict exactly what kind of penguin we have, classifying the penguins into different topics. And the features we're going to look at are these features here, just the measurements. It's very limiting, but we're going to see how powerful it already is just to look at these four. And how are we going to do that? we're going to use the scikit-learn library. This is the library for machine learning. Kind of considered the Swiss Army knife of machine learning. It really kind of gives you so much functionality in such an easy to use package. There's many available machine learning models. They're implemented by an expert team and checked by a large community. So that thing I said before about it being open source. And every API, or the scikit-learn API that you use, is very consistent across a variety of algorithms. And we'll see the benefit of that right at the end of this notebook. And it covers most machine learning tasks that we have. So this could be building the model, it could be pre-processing, or it could be building pipelines. It covers way more than what we're going to see today. It really is like most machine learning tasks that we need. It's covered in this library. And there's an ongoing commitment to the documentation, consistency, and usability of this library. So you know you're in good hands when you talk about this library. Some libraries, you know, anyone can create a library, but this one's really well documented, really, really consistent and really usable. And it's designed to work with our other key libraries. So we haven't talked about NumPy, but we've definitely used pandas. Great. We're just doing one step up. So let's go ahead and do it. Let's load in our data. So a little bit of information about the data, but we've before used the CSV file. This CSV file is actually generated from a data set that's available in Seaborn. So Seaborn was a visualization, but it actually has data available for us as well. So you'll find this with scikit-learn. There's data that's available in the scikit-learn package. There's also data available in Seaborn, and that's actually where we're going to pull it from now. And it's going to be a little bit more clean than the data we've just seen. The reason I'm doing it in both ways is just to show you like how available data is for you to really start picking up and having a play. So let's import some libraries. They're going to be useful for us in a bit. Let's create this penguins data set. This time we're going to use it doing load data set from the Seaborn library. But you'll see it's the same data that we are comfortable with, that we're happy with. We've got this, you know, it's back to millimeters, it's male and female. We no longer have penguin ID. So someone who asked, do we need it? We actually don't for machine learning. We don't need that ID. It's not going to tell us anything. We're not going to be able to predict anything from a randomized ID that gets given to these penguins. So that's why it's not here. And we can sort of look at things that we've seen before. We've seen these 3 islands before. It's exactly the same data. So just to convince you that we're working the same data. And I guess let's have a look at the species, maybe change up the species. These are the things we're trying to predict. Okay, let's prepare this data a little bit. So I'm going to give you another task to do to prepare this data. And what do I want you to have a go at? Think about what we did before. We've still got missing values. So we need to go ahead and get rid of those. Why do we need to do that? Well, scikit-learn assumes that all the values that you have, that you're predicting on, that you're using, are numerical and that they all hold meaning. So they can't be missing. So first of all, they can't be missing. And also they can't be non-numeric. So think about the sex that we had and the penguin islands that it was spotted on. We want to get rid of those. We could use them in a certain way, but it's a bit out of the scope of what we're doing today. So I just want to drop those fields. So I'll just give you a minute now to try, and here's the syntax again. Try doing that. Try doing that in a pandas pipeline. So taking that penguins, and we're doing some methods. Give that a go. I'll give you a minute. I'll give you a minute or two to have a go at that. And then we'll go through the answers. And again, if you're unsure or you don't have the notebook, just have a go at writing it down. I actually found one of the best ways for me to learn Python was to actually write it down on a piece of paper, because you can't just quickly check and see if you're right. It actually really got me thinking about it a different way. Okay, so just under a minute there. I'll give you one more minute to see if you can come up with that full chain. Okay, 20 more seconds and then we'll go through some answers. Okay, so obviously if we were in a real training, there'd be a lot more of this, a lot more time for activities, and I'd probably put you into different rooms and in smaller breakout rooms to have a go. But we're working with just the 2 hours, so let's, full steam ahead and let's go for it. So I've got the syntax just here. Drop NA we saw before, it's nice and easy. Drop, again, nice and easy, but we just need to drop 3 columns this time. So we want to drop species, island, and sex column. So, in fact, no, sorry, we don't want to drop the species just yet. Let's keep that in there, but we want to drop the island and the sex column because we need to keep species because we need to be able to predict to it. So species, the thing we're predicting can be a string column, but the other 2, we can't use these to predict, so we're going to get rid of them. They're not important to us. And because we're doing 2, unfortunately, we can't just sort of list them out one after the other. What we need to do is we need to surround them by square brackets. So if I just highlight the 2 that I have, I press my square bracket or put a square bracket around both of them. And then I'm just going to do comma, axis equals 1. So remember just saying that it's dropping it from my columns. And I'm just going to overwrite that data. I'm just going to overwrite it. I'm happy with it. I would suggest never overwriting the data unless you're in a safe environment like a training room, which is what we're doing now. But we're pretty happy that this is correct. If you're a bit unsure and you're not kind of sure if you've done it correctly, don't worry. You can look at it on here, which I guess is very similar, but it's just done a little bit of a different thing here where it's listed the unwanted columns, but exactly the same steps are being taken. So if you don't want to do that, just use these answers. And if you get any problems, just read in the data again and then apply this. But now we have some data that has, well, I guess I can't run this, but that's absolutely fine. Let me just, now we have some data. And if I look at my data, I have a data with the field, the target that I'm trying to predict. So that's what it's often called, target or flag that I'm trying to predict. And then I have all my predicting variables, all my independent variables that are going to tell me something about it. So I'm going to be able to say, is this bill length telling me something about what species? And if I combine it with the bill depth, the flipper length and the body mass, am I going to be able to predict this species? So what do I need to do a bit further for preparing this data? I actually need to split these 2 things out. So scikit-learn always needs a feature matrix, which is called X. So conventionally we call it X. And a target vector, which is called Y. So what is X? X describes the data. It's the attributes the base predictions on. So it's all those measurements that I've been talking about. The shape is 2-dimensional. So it has some columns and it has rows going into it. An example here, for each penguin, we have the bill length, depth, body mass, and flipper length. So it actually is like the number of penguins that we have, which I think was around 340-ish, times by 4, because we have 4 columns. Where the target vector Y is literally just that one variable that I mentioned, the species. So its shape is just N, it's 1-dimensional, just goes 1 column down. And it's the label that we want to predict, which is our species. And here it is again, we've got 200. So if we have a record of 200 penguins, Y would contain the corresponding species for those 200 penguins. And there's 3 different options, but it's still just that 1 column that goes down. So we're going to use our knowledge of pandas to do this. We're going to first of all create X by dropping species because we don't want that to be involved in our feature matrix. So we need to drop that out of it. And then with Y, we just need to select just that feature, just that one feature. So now if I go ahead and look at the shape of these, I have 4 columns in my X matrix. Those are what I'm using to predict. And in my Y, I've separated out, that's what I'm trying to predict. And I haven't got, it's saying it's 333 down, but no columns long. So it's 1-dimensional. I can look at it a little bit further. Here's the head of the data on both accounts. I've got 4 columns, makes sense. I no longer have that species because imagine if I did have it included if I built a model, the model would just say, well, you're trying to predict these species. Here's a column that says species. That's how you can find out. But in the real world, we're not going to know their species, so we have to get rid of it. And then if we look at y head, that's my predicting variable. So I need to keep it, but I keep it separate. Okay, so we're almost there. We're almost there with preparing our data. There's one thing that we finally have to do just to really be robust when building data. And a lot of people, when they're learning, when they're starting out with machine learning, try to kind of get around this step, but it's very, very important. And it's all about splitting the data set. So an important goal in machine learning is to create a model that will be able to predict not just on the data that we have, because what we could do is we could say, we've got this data, I'm going to build a model. Does the model predict well on this data? Well, that's great, but we're not really seeing what's going to happen in the real world. What if tomorrow I go back to the Palmer site and I try and use the information I have about penguins to predict what species they are? Is my model going to be general enough? Am I going to be generalized enough for it to work in the real world? So imagine this, we have a penguin A and it's a Gen 2 penguin and it has some features, it's got bill length of 33, depth of 16, flip length of 180 and a body mass of 3,500 grams. Okay, this penguin was present during when we trained our model, when we actually built the model. So that means penguin A was one of the examples that the algorithm that we're going to see is used to create the understanding of what Gen 2 looks like. So it's really going to be kind of, if this was a bit of an anomaly, it'd really sway that model to sort of consider Gen 2 penguins of anomaly values. Now, if we were going to actually, see how well the model does, if we ask the model to classify this specific penguin, it's not really going to give us a lot of information. Even if the model is fully correct, do we know whether it's really truly learned the relationship between the features and the targets, or has it simply remembered that penguin A? Has it really has taken that to actually make its predictions, and is it just remembering that? So we want to separate our data into two parts: the training set and the test set. So this is typically what they're called, training and test. So this is the data, the features and the targets that will guide the learning process, where we'll keep something separate so that once we have a model, we can actually evaluate how well that model is learning. So the train test split function allows us to split this data. This is straight from scikit-learn. Look, this isn't just us building a model. This is taking scikit-learn and actually applying something that's not particularly model based, but it's all to do with how we build our models. So by default, it will have a test size of 25%. So typically, your test data will be a smaller majority of the data. 25% is the default. We're actually going to have it as 30% for this. There's no real standard. It's kind of up to you and the data that you're working on. I've always done with 30%, but that really makes sense for the data that I've worked with. You might need to have different size, a smaller size, depending on how big your actual data is, because you need enough data to be able to train on. Your data needs to see enough examples, because imagine if it only saw 3 penguins, well, it would only be able to have, and there were 3 different types. That's the only information it would have about those penguins. It wouldn't be able to get anything more information. So we need enough to be able to build. So for this data set, 30% in the test and 70% in what we're going to build is pretty good. And this is the syntax to do it. It's a bit long, but we have our X train, then X test. Then we have our Y train and our Y test. Remember that X was the features and Y was the target variable. And then we just apply the train test splits function, which we're importing here, by feeding in the X, the Y, and then saying exactly what a test size it's going to be. And all I'm doing here, if I run this, I'm printing out the shapes of those data. So you can see the size of our feature metrics for the train set is 233 rows long. So remember, originally I had about 340. Now I've chunked that to 233. And because it's my train set with the features, it's 4 across. But for Y, the target vector, it's none across, so it's just one dimensional, but has the same amounts. So you can see it's exactly proportion that, so that those data sets are going to match up. So the X's are going to match up to the Y's, which is really, really clever. The size of our feature matrix for the test set is 100. So you can see that this is much larger, and actually it's around about 30%. So I'm not going to do the maths on the top of my head, but it's around about 30%, and this is around about 70% of that original 344, or 333 in this case, because we've got rid of those missings. And again, feature matrix is 4, but target is one-dimensional. Another thing great about this, it takes it in, it looks at the order, so it can match the predicting variables to the target, make sure that they're always going to, this is going to relate to this one, it's going to relate to this one. But then what it does is it shuffles the data so that you don't have it all in order. And if we actually look at it now, we'll see that it's shuffled. So it's actually doing a little bit further step for us as well. So we don't sort of feed in a model that is already kind of telling us something about the order that it's in. So originally we had Adderley at the top, and I think it was in alphabetical order, but now it's a bit more shuffled. So now that we've prepared our data, so again, even though we did some data cleaning in the last step, which was just in pandas, we still had to do some data cleaning in this step to prepare our data. But now our data is ready, we can actually go ahead and create a model. So scikit-learn has a rich collections of algorithms that are really readily available to us. So depending on the case that you're working on, you would probably choose a different model to suit your purpose. So there's different sort of steps, so there's different ideas of what model you would choose. What we're going to do is we're going to pick a decision tree classifier. So we're going to build a decision tree, and we'll have a look at what that looks like when we've built the model. But there's loads of different ones that we can use as well, and it really depends on your use case. We're not going to cover kind of how you'd want to choose the model, because that's way out of scope. It could be, it could be a whole day just talking about how you choose your model. But we'll just have a look at a few examples and maybe see what the performance is for each. So the steps that we need to take. So first thing is we choose a model. Well, we've done that. We're going to use the decision tree classifier and we import it. Step 2 is to choose the model hyperparameters. This we're not going to really get into, but there might be some sort of specific things that you have, maybe some measurements that you use that you need to be aware of before you actually train your model. And then we train the model. We train the model to the pre-processed data. So we've processed our data, we've prepared it, and we use the fit method. And then we evaluate the model performance. So really it goes import the model, instantiate the model, train the model, and then fit the model. No, sorry, fit the model. So you train the model using .fit. Then once you fit, you test it. So it's kind of import, instantiate, fit, performance. Those kind of 4 steps. So let's have a look at this in action. So step 1, import the chosen algorithm. We're employing decision tree classifier. If we run help on this, we can actually get some information about how that function is set up. And we get loads of information about different parameters. And this is what I'm talking about, the hyperparameters that you might need to choose. Maybe for your company, you're more interested in building a model towards entropy rather than Gini. Gini is the default. It's what I'm very much more used to building to. And it really, Gini just looks at how well are you doing at distributing the different classifications that you have. How well are you kind of pushing those out to the boundaries that you have. But there's loads of other things as well. You can determine what kind of splitter you have and how deep your tree is going to go. So you'll see as we get further down that you can split, your tree will split out into different options, but you can decide how deep you're going to go. And there's so much more that you can actually see if you scroll down how much more there is. What we're going to do is we're actually just going to take in the default values for each of these, default parameters for each of these. So we don't actually need to worry too much about what's going on in here just yet. So what we're going to do is with the decision tree classifier, we're just going to instantiate the model. So this is very typical code that you will see is just saying model is equal to decision tree classifier and just instantiating that, calling that function. And now that you have that model and it's ready to go, you literally just take that model and you fit the data to it. And remember, we're taking that train data. So let me just run this so my model's in existence. And then we train the model using the train data. So we take our X train. So it's always X then Y, always X then Y. And we fit our model to the X train and we're predicting it, seeing how well we can predict the Y. And nothing gets output just yet, but we can see that it's run. We get this kind of object that gets outputted, the decision tree classifier model. And now that we have that fitted, we can use the predict method. So we now have a trained model. So remember our test set, this is where it's going to come back. So we're going to use that to see how well we're predicting. So we're going to say our Y predictions are going to be the model, and we're going to predict the X test. So look here, we've trained on X train, Y train. Now that the model's sort of working, we can actually say, right, how well are we doing? Let's predict from our unseen data. Let's sort of look at the unseen data. Let's look at the bill depth, the bill length, the body mass, and let's see if we can actually predict from the X test. So now we have our predictions. So you can see here exactly what's happening is it's taking in this X test and it's just spitting out, I think the first one is a Gen 2 penguin. The next one is chinstrap. The next one is Adelaide. The next one is chinstrap, and so on and so forth. And we can compare these against the original data. So here I'm just looking at the top 10. So I'm just looking at the top 10 predictions I have. Here was the original. So this is my original test set. This is my original Y values. So Gen 2, okay, I got that one right. Chinstrap, didn't actually correct that one right. But Adelaide, I got that one right. Chinstrap, I got that one. Okay, so actually, I think it's doing pretty well. Maybe it's not doing so well with chinstrap and Adelaide, but the Gen 2 ones it seems to be finding. And for most of the part, I think I've got about 80%, 70% correct in just those top 10. Fortunately, we don't have to just look comparatively. Scikit-learn to the rescue again. We have a performance metrics that we can take out, which is the accuracy. So it's saying how much of these have we got correct? So out of the 10 that we corrected, so out of these, sorry, just the first 10, how many did we get correct? And I think there were 7, so that accuracy of 70%. But what about the entire data set? So the entire 333 penguins or the 100 penguins that we had in our test data. Well, let's import accuracy score. So again, we're going to be importing from scikit-learn, but look where we're importing from scikit-learn this time. We're importing from metrics. Before we were importing from tree. So there's different areas like scikit-learn. You can already see how deep it's going to go. So from this area, we're importing from the metrics and we're importing accuracy score. And then we feed in the accuracy score, we apply that function and we feed in the Y predict, then the Y test. So it's when you're pulling these functions in, you always kind of go X then Y. And then when you're doing accuracy or performance, you always do predict then test. It's always in that order. Make sure you don't get the wrong way around. Otherwise, you're actually, yes, for accuracy score, it wouldn't make too much difference, but for the other ones, it would actually change your performance a little bit. So always make sure you do it in the right order. The great thing is that if you, let's just go ahead and run this first. If you do get confused, you can hit Shift and Tab when you're in the brackets, and it will tell you exactly which one. I mean, it says Y true, but that means, oh, actually, I think this is the wrong way around. But I guess for accuracy score, it doesn't really matter, but it's better to make sure we're doing the right way. So Y true, which is the original test that we had, and then the predictions that we've made, which is Y predict. And we can see an accuracy score of 0.94. Now, hopefully you're not thinking that 0.94% is not very much, but it's not, it's 94%, which is pretty good. But it's not the only metric we want to use. So why is it not the only metrics we want to use? Because we're saying, you know, we're correct 94% of the time. That's pretty good. A good thing to think about is if you're thinking about accuracy score and you think, what if we weren't doing penguins? Okay, what if we weren't doing penguins? What if we were looking at emails and we had 1,000 emails that we wanted to predict that were coming in, and we wanted to predict whether they were good emails or they were spam emails. Our model that we make is 99% accurate or 99.9% accurate, which is great, sounds great, but that model isn't picking up any spam emails. It's not actually identifying any spam emails. So how has it got such a good accuracy score? Well, if you've got 1,000 emails and then one of them is spam, your model could just say, there's no spam emails. You know, you haven't actually got any spam emails. That accuracy score is going to say you've got 999 non-spam emails out of 1,000. Those are the ones we managed to identify. Yes, we missed the spam email, but we're actually at 99.9% accuracy. So hopefully that kind of explains why we want to go a little bit further, why we want to look at further performance metrics. So alternatives then. So we have alternatives, for example, precision and recall. So precision is the proportion of positive identifications that were actually correct. So if you think about the penguins that we're looking at, if we're saying, okay, these ones are certain, these are Adelaide or Adelie, and these ones are Gentoo, these ones are chinstrap. That's what we've said, but how much of those are actually correct? So we're not really interested here in the ones that we said are different. We're interested in like saying, right, you know, we said this one was an Adelie. How much of those were correct? And if we said this one was Gentoo, how much of those were correct? And we said chinstrap, how much of those were we actually correct on doing? How precise were we in our predictions? Recall is kind of the opposite. So it looks actually, instead of what we're predicting, it looks at which ones were actually Adelie, which ones were actually Gentoo, which ones were actually chinstrap. And out of the chinstraps that there actually were, how many did we manage to recall? How many did we manage to grab and say, yes, those are chinstrap. Same with the Gentoo, same with the Adelie. So how much are we actually able to grasp back from what's actually there? I find precision and recall one of the hardest things to really get your head around because there's so much really going on. And further from that, to even make matters even more complicated, there's the F1 score. And it's a function of both those two things, precision and recall. And you can use it to really try and seek a balance between the two. It's the kind of weighted mean of precision and recall together. So it's a way to look at both those things in one figure without it being kind of making one go up and making one go down. You can kind of combine them. So why am I spending so much time on this? Why is it so important? Well, in some cases, precision might be more important. So here's an example. If you're on YouTube and you're building YouTube recommendations, so if you're trying to say for customers, they're watching certain videos and you want to make sure that you give them some really good recommendations, you might not be able to show all relevant videos, but it's important that the ones you do show are relevant. So it's probably more important that you are more you're more precise in the ones that you're giving to them. So you'd rather them see fewer recommendations that were more accurate to them, rather than seeing 100 recommendations with only 70% being accurate for them. So in that case, precision would be more important. However, maybe you're in a medical context and recall here would be much more important, because if you are looking at imagery and you're trying to look at images and sort of detect cancer, and you go up to you go up to a person and you say, no, you're absolutely fine. We're confident that you're fine because of this model. It's going to be much worse for them. It's going to have severe consequences if they're actually not, So what you probably want to do is you probably want to be overly cautious, and you probably want to say, oh, actually, no, we're a bit concerned. We want to do more tests and get that further, because if down the line, it'd be much easier to then say, okay, actually, no, you're healthy, than to send someone home and then actually have to call them back. So with medical context, recall is often much more important. From a personal level, when I worked in credit risk, it wasn't so much important to look at these, but it was much more important to look at, if we take on this many people, if we give out this many loans, how much could we potentially lose in the future? So we have to look at precision and recall to really balance it out in terms of how much money we need to set aside for those people who might end up not being able to repay. So there's different considerations that we have, and precision and recall is really good for sort of steering us in the right direction. So again, from metrics, from scikit-learn.metrics, we're going to import the classification report. Classification report just shows us pretty much everything that we need to know. So we create our report, again, doing the, I think this is the wrong way around again. Apologies for this, but Again, it shouldn't matter, but they'll be in different places. So you don't want to say to someone, this is the precision recall, and then it's actually the other way around. So yes, so you have here the precision. The precision is probably not so great for individual ones, but I guess you see, we're 80% correct when we're looking at chin strap, but we're much better identifying the Gen 2. We're much more accurate. All the ones that we said were Gen 2 were actually Gen 2, but we did miss here, we did miss 3% of the ones that were actually Gen 2. Okay, all the ones we said were Gen 2 definitely were, but we are still missing 3%. So you can see kind of the measurements between them. You can see this kind of joint weighted average between them. And then you also get it on a total level. So you get the weighted average. This is probably the one you want to be looking at for precision and recall. And actually they're both relatively similar, but it depends how you want to do. Do you want to push up one and pull down the other? Maybe you can have a certain cutoff of how reliable you think you are. Okay, so we've covered a lot there. What I want to just do is really visualize the model that we've created. So if you haven't seen the decision trees before, I'm just going to run this cell. And the real advantage over decision trees over some of the other models that are available, they're really easy to interpret. They're easy to visualize and really easy to interpret. So we can see exactly what's happening in the model at each time. So you can see exactly what it does. It says at the beginning, right, look at just the flipper length. So this is usually how decision trees are set up. It will take one. So I kind of think of it as if you ever read those kind of magazines. When I was a teenager, I used to read these magazines and it would say, how much of a gossip are you? And then it would say, do you ask your friends for gossip or do you let them come to you? And you go down these different branches and then you're on these different branches and then it's, do you read magazines or do you not? And you go down and then at the very end, you get to kind of different categories and it says, you're 100% a gossiper and then you're not so much of a gossiper, So if you remember those or if you ever used those when you were younger, then you get to remember. If not, then we'll explain it in the mathematical way. So here what it's doing is it's taking just the flipper length and it's saying if the flipper length is less than or equal to 206, go down this branch. But if it's over, go down this branch. So it's saying that this cutoff here of 206 is quite telling to be able to predict what kind of penguin we have. But that's not the only thing we have to look at. We have other things as well. So the next thing it looks at is bill length. So it says in this category on the left side, if it's less than or equal to 43, go down the left-hand branch. But if it's greater than that, go down the right-hand branch. And then it continues that kind of pattern. So bill length over here again splits it by 17.65. It actually stops here at one point. So it doesn't always have to get right down to the same level at the bottom. It's saying here, I'm pretty confident that at this point, so I'm looking at this kind of on the right-hand side, and then it goes to the left. I'm pretty confident it's Genie here. Genie, the class here is Gen 2. So I'm pretty confident that we've got some Gen 2 penguins here. And knowing what we saw from before about how accurate we were, we can tell that these are actually going to be Gen 2 penguins. If we look at how it happened going the other way, we were pretty sure that they were chin strap, but then when we split them even further, we could go even further detail and say, actually, no, because of the bill depth, I can say that these ones are Adderley and these ones are chin strap. So you can see exactly how it's kind of splitting these out and exactly why we call it a decision tree. Okay, just as we're getting towards the end here, we're going to look at choosing a model. Just want to have a breather and just let you have a think about what we've covered. If you've got any questions, please feel free to either come off mute or put them into the chat. I did get one question when we were going through, and it says, why is it uppercase H, but why is it uppercase X, but lowercase y? It is just convention. You can call it anything you want. You could call it penguin matrix, you can call it whatever you want, but that's quite long to keep writing. And it's so conventional to have uppercase X, lowercase y. That's much easier to read. Why it's uppercase and why one's lowercase, I'm not sure where that actually came from. Maybe that'll be something I look into because it's an interesting point. But it is just like convention. Okay, I'll pause there then just for a few seconds just to let that digest. And if you've got any questions, feel free to put them in the chat. And then I'll move forward in about 10 seconds or so. Okay. Hopefully I kind of, sometimes I think it's good to just take a step back and think, we've done a lot there. And this notebook is very, very cumbersome. There's a lot going on in here. The final thing I want to just cover is we've only looked at decision trees, and this is an image of a decision tree. And hopefully you can really see why it's called a decision tree. And hopefully you can also see why it's so sort of easy to understand and easy to suggest. If you present this to a stakeholder who's maybe not so technical, they can visually see exactly what's happening each time. But there are other models that we can use, and maybe explainability isn't actually as important, and maybe we want a little bit more model performance, and we want to sacrifice that explainability because we really need to be accurate, maybe going back to that medical example. So maybe we want to choose a different model. And here it's up to you. You can go ahead and try out these different models. But I've got a few here. So the first one's a decision tree classifier, exactly the one that we had. And all you can do is if you want to just try it, just go ahead and uncomment just here. You can just click on this bit here and just delete the hash, which is just giving us a comment. So a hash, it's kind of similar to SQL, double dash is a comment, but here it's a hash. Get rid of that. Now we've already done the decision tree. And we can see our accuracy is slightly changed. So I guess it's because we haven't selected a certain seed or because we're doing it in a different way. We're doing the score of it. So it works out a slightly different way. But we've still got our model accuracy. We've got our precision as well, which was exactly what we saw before. Precision was 100% for Gen 2, but 97% for recall. But if we want to try something else, we can uncomment. We can comment that back in, and we can uncomment the next one. Random forest. So if you haven't heard of the random forest, then this is probably the easiest one to go to next, because if this is a tree, a random forest is just loads of these trees that work in different ways. And essentially, if you have 100 trees, it's like going Who Wants to Be a Millionaire, if you remember that show, and you ask the audience, and the audience will say, what they think the answer is. 60% say that the answer is A, so you think it's going to be an A. Works in exactly the same way. Instead of having audience members, you have these different trees, 100 trees, 60 of them think it's an Adelie penguin, 20 of them think it's a Gen 2, 20 think it's a Chenstrap. You're going to say, okay, I'm going to go with the majority. I'm going to say it's a Gen 2 penguin. And we can go ahead and try this and see if we improve on our accuracy at all. And that makes sense that we improve it. It's less easy to digest because think about having hundreds of these trees next to each other. You're not going to be able to get that information into your head. But we are going to get a little bit more information, a more power coming out. And again, we can try K nearest neighbor. Not a very good accuracy score there at all. But essentially what that's doing is it's looking at the clusters of species that we have and saying, okay, we look at this one species here, how many of those, like if I say the 3 nearest to me are also that species, it tries to cluster them in that way. So that's how the K nearest neighbor is working. And you can see it's not actually working that well for us. So maybe the decision tree classifier, if we're not too worried about explainability, maybe that's the one we would want to go with and maybe fine tune a little bit more. Okay, that brings us to the end of the 2 hours. So thank you so much for staying with us and talking through. I hope that was really useful. We also have one last thing, if people are up for it, which is a Kahoot quiz on what we've just done. So I'll see how many people join. Hopefully everyone's sort of interested in doing this. And it's just really going to see how well you've picked up what we've talked about. So let me get this working. And this one just here. Okay, so if you grab your phones and if you go to kahoot.it, I'll put copy and paste this into chat, but try not to do this on your computers, much better on your phone because you'll have to look at my screen and your phone. So here's in the chat. And then if you can input, when you get there, input the game pin. And then you can put your name in, or you can just put a pseudonym in if you don't want to if you don't want to put your own name in. But we'll see how far we get through in the Kahoots. Maybe you've already played it because we're all so used to working from home and these different tools that we have. So I can see Bob's in there. Okay, we'll have to have a few more players than just Bob. So hopefully people are up for this and joining. Okay, lovely. We have another person. Nice. Okay. Okay, I'd like to have like at least two more people to join. Would be lovely. Random stranger, nice. And Indy's joining us, very, very nice. I'll give you a few more seconds just to join because I'm just want to make sure that people are all in. But thank you so much, those four, for joining. It's lovely to see you. Okay, we have five going in. Okay, right. Let's get started because we only have 8 minutes left. I want to see how far we can get through this quiz. Okay, so all questions to do with what we've done today. You'll see the question on my screen and then you'll need to answer it. Click the right color on your phone. So let's go ahead and start. Okay, data science taster. Okay, first question. What method will give you statistics on all your numeric fields in a data frame? So which one do you think it is? Which of these methods did we see that gave us the statistics? Okay, oh, one person. Okay, I wonder who it was, but yeah, we didn't actually see info, but info is really similar. But yeah, it is the scribe that does it. So it's not just answering correctly, it's answering quickly. So we have Bob at the top, fast fingers there. Okay, which is not a common plotting library in Python? Okay, yes, pandas can plot, but it's not common to use for plotting for actually creating plots. It's good for like quick visualizations, but Plotly is another one that's actually really useful, really much more powerful than just that plot method in pandas. That's actually built on top of matplotlib, so a little bit of a trick question there. Nice. Okay, Indy's at the top now. Okay, let's keep going. Okay, why do we use scikit-learn? Why do we use it? Okay, oh, nice. Yeah, there's 2 correct answers there. There's many available machine learning models for us to choose from, and the API is consistent for a wide variety of algorithms. The green one's more to do with SciPy, if you know the library, and yellow, yeah, it's not great for interactive visualizations. Other libraries much better. Okay, random stranger on answer streak, nice. Okay, what of the following will scikit-learn not allow in your training data? Okay, yeah, very cool. So it's missing values. So remember we had to get rid of those with drop NA. Discrete values can be numeric. It could just be like a count like 1, 2, 3, 4. Dummy features, we didn't talk about dummy features, so a bit of a nasty one throwing that in, but dummy features is really just a 1 or a 0. So if you had kind of maybe the female and male, you maybe just change that to be, the column would be is male, and you'd have 1 for a male and 0 for a female. So it's kind of a yes or a no. But very well done for those 4 people. Let's see where we are. Okay, oh, changing around. Bob's coming back up. Okay, why do we split the data into train and test? Why do we split it into train and test? Okay, oh yeah, so scalable and easy to replicate. That's not one of the things that makes, there are other things in scikit-learn that will allow us to do that, but it's really this idea, we want it to be generalized and want it to perform well, and to be sure that it performs well under new circumstances. Okay, random stranger pushing their way up. What's the best predictor or the best performance metric for a model? Okay, yeah. So apologies, this was very much a trick question, but all should be used. There's no real best predictor. It depends on the model that you're using. Accuracy could be really good, but I'm glad no one put that, because precision and recall and F1 score do give us a little bit more information. But yeah, all of them should be used. Okay, oh, random forest. I didn't see that character. Okay, what species did we classify today? No, did we not classify today? So we saw 3. Which one's not one of those? Yeah, finally we've got one with everyone got the right answer. Nice. And then lastly, where can you go to learn more about data science and machine learning? Okay, all of them correct. Even Antarctica, because you could go back and collect more information about penguins. But hopefully you'll do some of these. We've got some Exedio and Go Data driven website information. And we've also got some courses if you're interested in learning a little bit more. Let's see then who got the top spot. Number 3, random forest. Nice, random forest. Top spot for name choice though. And who was top? Random stranger. Okay, brilliant. Well done. Thank you so much for playing. Bob, I thought you were going to make your way back up because you were at the top at the beginning, but well done to Random Stranger. 8 out of 8 correct. Pretty great. Okay. So just going back to my final summary. So we've done a lot today, like I've said. I really hope you've taken something away from it. I hope it's inspired you to learn some more. I'm sure like there's something that you kind of still thought, I didn't know that before. I really hope that's something as everyone's taking that away. This is what we've done in scikit-learn. We've done the train test split. We've looked at the metrics. We've looked at actually building models. And what can you do to learn more? Well, we've already talked about it, but there's public courses that are really specific for this knowledge. We've got a Python for data analysts. We have a certified Python for data science. We have an advanced Python, advanced data science with Python course, much more. We have deep learning. We have time series. We really get specific with our training. If you're interested, we've got our training guide here if you're interested in downloading it. Please check it out if you're interested. I'd love to see you on the course in the future. We'd love to get, it's great to be able to do it at different time zones and make it more available for different people. So please check out and see if there's anything that's available for you, or reach out if there's not. But it was great to see that many people. If you have any questions, I can stick around. I'll drop my information into the chat as well. But thank you very much for following along, and hopefully see you soon. I will stop my share now.
Thank you so much, Lucy, and everyone here for joining us. We will update you with the upcoming webinars, and if you have missed any part of the session or want to see it again, we will provide the recording soon. Also, you can tell us your experience about the session by using the link I'm putting in the chat. So you can let us know about the experience. Thank you so much, everyone.